Welcome and hello. This is a support video in HEC RAS. We're going to be moving multiple cross sections horizontally. So if you see right here in the plan view, I have 6 different cross sections. I want to move them all horizontally by changing their northing and easting value. Say, for instance, the projection data gets goofed up and you need to make some sort of corrections. In this video, I'm going to describe 2 different ways to make that happen. I should probably mention there are some ways to modify individual cross sections. So for instance, if I wanted to move this cross section right here, I could just click on it and then move upstream or downstream, and then boom, it's moved. But we're not going to talk about that. That can be for a different support video if necessary. You can also draw in new cross sections as well. So the first way to modify the horizontal offset of a group of cross sections is to use RAS Mapper. So I'm going to go up to GIS Tools, open up RAS Mapper. Let's see. So here is my geometry. As you see, I already have a terrain, a river line, bank lines, cross sections. I'm going to just toggle off the terrain here so we can see things a little bit better. Don't need edge lines either. Right. So one way to modify multiple cross sections at the same time is to right click and edit geometry, and then just go ahead and click on your cross sections, click on edit, and then highlight all the cross sections you want to change. So now when I have them highlighted, the cross sections are magenta, which is true right now. And if I just click off, they are unselected. If I only want to select these 3, I can just highlight those 3. I think you can also just highlight them one at a time and then hold down the control key. Yeah, so you can just hold down the control key if you wanted to highlight multiple non-adjacent cross sections. Okay, so I'm going to go ahead and just select all of my cross sections. Keep in mind, I do have cross sections selected over here in the left menu. That's what's allowing me to select just cross sections and not other elements within the map. And say, for instance, I wanted to move all of my cross sections to the east 1,000 feet. So down here, I see the scale here. That's what gave me the idea to say 1,000 feet. So I could just translate them over 1,000 feet. To do that, I would just use the mouse and then move them over 1,000 feet. Now, it may not be what you want to do. And that was, of course, not very precise. It probably wasn't exactly 1,000 feet. But if you zoomed in enough, you could probably get it fairly precise. It sort of depends on the level of precision that's required. Of course, you'd also want to move some of your other elements like the bank lines and the river lines. So I'm going to click on the finger pointer so I can pan around. Right, so that's how you can move multiple cross sections at once. I'm going to go ahead and close that and not save the edits. So let's open up the geometry again. Okay, good. So that did not save. I didn't want it to save. And let's see. So yeah, we're back where we started here in RAS Mapper. If you wanted a more precise way to modify the position, the XY coordinates of these 6 different cross sections, then I would open up and make edits to the geometry file directly. So this is my project directory. This is my geometry file. Let me scroll to the top, and boom, we have some header data. We have the alignment of the river reach, and then after that, we have all of the nodes. So this file goes down about 500 lines because there's just a lot of cross-section data. Okay, so this is the first node. We know it's a node because the text starts with type rm length lchr equals. 1 represents a cross-section. If it's not 1, it's a node that's not a cross-section, like bridge, a culvert, inline structure, or something like that. The river station, downstream distance. And then right here, this is a specific substring that I'm going to use when I write my script. We're going to be writing a script and then updating this line of code right here. Line 23 happens to be the location where it describes the alignment of this particular cross section. What we're seeing here is 16 characters that I'm currently highlighting, boom, to describe the easting value of the first point when looking at the cross section from left to right in the direction of flow. After that, this 4036774 number all the way to here is another 16 characters. That is the northing value of that first point. And because we only have 2 points right here, 2 points to define the alignment of that cross section, the XY horizontal coordinates, and that's why we only have 2 points right here. The second point begins right here, I believe. Yeah, so that's going to be the easting value of the second point, which is the far right edge of the cross section. And then right here is going to be the northing value of the second point of the first cross section. If I scroll down to the next instance of this type rm length LCHR equal sign substring, I'm going to go ahead and copy and then just find all the instances of that. So the next one down is right here. This happens to be a cross section with 3 different points to define the cross section. It doesn't always have to be 2 points. So here are the 3 points. Next one down is right here, River Station 2556. That has 2 points. So what we want to do is take the northing and easting values and then translate them by a constant offset. Maybe it's 500 feet, maybe it's 5,000 feet, whichever distance that you determine needs the correction. All right, so to do that, I've gone ahead and written a Python script right here. So I'm going to just take you through a quick example of how to do that, and then we'll load this newly created geometry after performing the offset, or what I'm calling a horizontal translation, back into HEC RAS, and then we can check to see if the update was successful or not. So what I'm doing here on lines 4 and 5 is I'm specifying how much I want the offset or the horizontal translation to be. So for instance, if I want the easting to increase 2,000 feet and the northing to decrease 3,000 feet, then that's where I would enter those values. Of course, it may not be nice, clean, rounded numbers like this, but that's what it is for this example. After that, I'm going to be opening up that geometry file. So this is an absolute file path to that G01. And then I'm saving that text inside of a file new text string. And then in the remainder of the code here, I'm just going to be updating this file text string with the same values for the northing and easting, except I'm going to find them. I'm going to parse them out, and then I'm going to, what I say, add 2,000 to the easting and then subtract 3,000 from the northing. Then I'm going to be updating this file new text string. And then at the very bottom, the last thing I'm doing in my code here is writing a new geometry file. It's in the exact same directory. However, it's going to be called project.g02. So if you're curious about the coordinates, for instance, here is our first node, which happens to be a cross section. And if I put my cursor over this far left edge of the cross section, you can see down here in the bottom right corner of the geometric data editor, we have the coordinates. So we have easting and then northing. So this is the easting. The numbers are going to change slightly, but if I just scroll in real close here, 614,565. Let's go back to that geometry file here and scroll up to the top for our first cross section. So 614,565. I think for the nearest foot is close enough just for checking data. And then the northing value would be 403,6774. So let's see here. 403,6774. That checks out. I'm going to go ahead and scroll up and then over. Let's check the right point for that same first node, the upstreammost cross section of our river reach. So the easting, I'm looking at 615,213, 615,213 right there. And then we should expect the northing to be 403,7585. So that is 403,7585.12 or something like that. Okay, so anyway, that's where those numbers are coming from. I also created an Excel file. I only created data for the first couple of points just to kind of help me understand what I'm doing. So for our first node or first cross section, we have 2 different points. And then the original coordinates right here for those 2 points are northing values, are easting values and northing values. And then the same, but translated after the correction has been made, will be right here. So instead of a easting of 614,565, we're going to add 2,000, and that's going to be 616,565. And then for the northing on that first point, instead of 403,6774, we're going to subtract 3,000. So the translated coordinate for that easting would be 403,3774, not 403,6774. This is just for the first two cross sections. The cross section 2 here has 3 points, but all the others have 2 to define its XY coordinates. So let's go back to the VS Code and just kind of explain what we're doing here. All right, so last thing I said was we have the original file. Next, what we're going to do is search through that geometry file's text and look for certain substrings that are hidden within each cross-section data or node data, such as this XSGIS cut line equals And then also node last edited time equals. Here is the .g01 geometry file. So here's the XSGIS cut line 2. That's the number of points. So here's the 2. And then after that, node last edited time equals. So this is basically going to be the start and the end. So everything between start and end is the coordinates that I'm looking for. What I'm going to do is remove all the line breaks and then be able to parse out for every 16 characters just to know this right here is my first easting, this right here is my first northing, and so on. That's what's happening in this loop right here. We're going to be looping through all of the matches. So basically think of it as all of the cross sections. And then down here, we're going to be looping through each of the points in the cross section. We're going to be getting a new easting and a new northing value. The new easting is going to be the original easting plus the easting delta. And then the new northing is going to be the original northing plus the delta of the northing. And then this line right here, just below it, is going to ensure that it is 16 characters long. And every 2 points, I'm going to be adding a line break. And then I'm going to just concatenate all the new coordinates together. And then on this line right here, line 50, we're going to insert that coordinate into where it belongs in the file. So in that geometry file, we definitely have some text that comes before the coordinates, the updated coordinates, and then all the text after the coordinates. I'm going to do that over and over for all the cross sections. And then, like I said before, at the very bottom, we're going to create a new file called G02, open it for writing, and then write our new text to that file. So if this runs correctly in the project directory, we should see a project.g02 pop up. So let me go ahead and just see if this works here. Move this off to the side, then save it, open up the terminal. I need to run this. So I've navigated to where I have the script saved, so I could just type in Python and then script.py is the name of this script file, and then hit enter and run. I've got some stuff printed out here, but basically that is successful. Here's my new geometry file, which was just created. Is that correct? Yeah, that is the current date time. Let's go ahead and take a look at our numbers. So I'm going to open that up in the same text editor. Again, everything should be the same, except for instance, this number right here should have an updated northing and easting. And this is again, just for the first of 6 cross sections. So let's take a look. 616565. And back to Excel, 616565 instead of 614565. Okay, so the northing updated should be 4033774. Okay, so we're looking at 4033774. Contrast that with G01, where we had 4036774 and 614565, whereas now it is 616565. Okay, so I'm satisfied that that's working. Let's go back to HEC-RAS now and close some of these folders that we don't need. Here's HEC-RAS. I'm going to create a new geometry file. I'm going to go File, it's about New Geometry. And okay, so I may have been messing with this earlier. I'm going to call this something else. I'll call this Base Updated. And then click OK. I think it's going to be G03. Yeah, so it's G03. No big deal. I can just change the file names. So here's G03. In fact, I could just paste the contents of G02 into G03. Okay, here's G03. I just opened it up. Here's G02. I'm just going to copy the contents of G02 into G03. Save it. Let's close that. Go back to HEC-RAS now. Now I should have some geometry data if I go File and then Open Geometry. Okay, G03 for Base Updated. We just zoom in here. So this should be, yep, very cool. So this is what I was expecting to see. As you can see, the river has not changed coordinates. We can do a similar operation to translate the coordinates of the river as well. But what we have is our 6 cross sections that have all been translated east by, what did we say, 3,000 feet, and then south by 2,000 feet, because this is not what we started with. We originally had the cross sections actually located on the river. Like I said, we could do the same operations with the river. All right, well, that's it for this support video. We talked about 2 different ways to horizontally translate a number of cross sections you may have in your HEC-RAS model. First was to just use the RAS mapper interface, edit your cross sections, and then drag them in the direction that you want them to be. The second option was using a script to update the geometry file and then change the coordinates of those cross sections to a specified offset that you want.